Bismillahirrahmanirrahim. Assalamu alaikum students. This is Tariq. In the previous lecture we were learning optimization application and we were discussing in the previous lecture revenue function example. Let me take you back to that example. This is example revenue function. For this revenue function, first part of the question is this: define the price at which revenue is maximum. We define the price. We find out that price. This P is equal to 0.5. And in the previous lecture, we defined the maximum revenue at P is equal to 0.5 as well. This is the maximum revenue, 5,000 billion of the revenue function. So, in the previous lecture, we discussed these two parts of the example. In this lecture we will discuss the third part of this example: determine the location and nature of the critical point of the revenue function, because every point of the graph carry two values, one x, other y. In this example, in the revenue function we use P as x and we use R as y. R represent revenue and P represent price of the commodity and R represent revenue of the company. So along the graph of this revenue function, every point will also carry two values, one P and other R. And now look, these are the two values that we have, critical point values. P value is 0.5, and if the company is charging price $0.5, so the company can earn maximum revenue $5,000 million revenue. So this is the critical point. Now in the next third part of the lecture, the third part of the example, we have to determine the location and nature of this critical point, which carry two values, P 0.5 and R $5,000 million revenue. So before this, we study optimization methodologies and we discuss condition for the location of critical point. What is the condition for the location of critical point? The point along the graph of the revenue function at which first derivative for the set of P value is equal to 0, that is location of the critical point. So look, condition is what? First derivative of the revenue function for the set of P values must be equal to 0, and we give this condition name 1. So if for the P value the first derivative of the function is equal to 0, then this critical point location is location of the critical point. So let me examine, let me check that for the P value 0.5, first derivative R prime of P is equal to minus 8P plus 4 is equal to 0 or not. So I am replacing for this P and for this P its value 0.5 in this first derivative of the revenue function. R prime of 0.5 is equal to minus 8, this is minus 8, and I am replacing for P its value 0.5 plus 4. R prime of 0.5 is equal to minus 8 multiplied by 0.5 is equal to minus 4 plus 4. R prime of 0.5 is equal to 0. Why this is 0? Because minus 4 cancel out with plus 4, and when the price is 0.5, at this point the revenue first derivative slope of the function for P is equal to 0.5 is equal to 0. So condition satisfied. What is the condition of the location of critical point? Condition is this: if the first derivative of the function for the set of P value is equal to 0, so that is location of critical point. So we satisfied P is 0.5 and first derivative this for 0.5 is equal to 0. So it's mean this is location of the critical point. Let me interpret. 8P is equal to 0.5. First derivative R prime of P is equal to minus 8P plus 4 is 0. So this critical point, CP 0.5, R 0.5, R this $5,000 million. This is the location of the critical point. In the next section, we will determine the nature of this critical point, this that this is highest point of the graph or lowest point of the graph. This is maximum point of the function or minimum point of the function. We will determine its nature of the critical point using first derivative test. So we will check. What is first derivative test? By checking slope of the function or first derivative of the function to the left of the p is equal to 0.5, and then we will check to the right of the p is equal to 0.5 the slope of the function. If to the left slope is positive and to the right slope is negative, then the graph of this function will be concave down and point will be highest or maximum point. So I am using the first derivative test. We discussed the first derivative test before this also. So I am applying here. This is our value, p is equal to 0.5. To check the slope of the function to the left of 0.5, I will take near value to the left of 0.5, which is 0. So PL mean near value to the left hand side of the p 0.5, which is 0. So I am checking r prime PL minus 8p plus 4 8pl is equal to 0. So r prime 0 minus 8pl is 0 plus 4, and r prime of 0 is equal to 4. This is positive slope. I am again repeating that PL 0, what does this mean? This means I am checking the first derivative of the revenue function or the slope of the revenue function to the left of the p is equal to 0.5 at nearest value. So to the left hand side of 0.5 near value is 0. So we replace for PL in here 0, and now at P0 this is slope of the function r prime of 0, which is 4, and this is positive value. So if to the left first derivative for the value which is near to the 0.5, if that is positive, so graph is increasing. Graph is increasing, slope is positive. And now we will check to the right of 0.5. P is 0.5. We will check to the left of 0.5 and we will check to the right of 0.5. So to the left of 0.5 we check at 0, which is the nearest value. That slope is positive. Now we will check to the right hand side of the 0.5. So what is near value to the right hand side of 0.5? That is 1. I am checking the first derivative of the revenue function at 1 to the right hand side of 0.5. So r prime of 1 is equal to minus 8, p is 1 plus 4, r prime of 1 minus 8 plus 4, r prime of 1 minus 4. So to the right hand side slope of the function, first derivative of the revenue function get negative. To the right hand side, to the left hand side, this is positive, slope is positive. To the right hand side, slope get negative. So this means that graph of this revenue function will be concave down, and the point is a relative maximum point along the graph of the function. So interpretation is to the left hand side of the critical point, slope is positive, and to the right hand side of the critical point, slope is negative, so graph is concave down and point is maximum point along the graph of the revenue function. Let me repeat again nature of the critical point using first derivative test. First derivative test we discussed before this, that we will examine, we will check slope of the function to the left hand side of the critical point and then to the right hand side of the critical point. If to the left hand side of the critical point slope is increasing positive and to the right hand side slope is negative, then graph of the function will be concave down and point is highest point along the graph. So this is our critical point, p value 0.5 and r value 5,000 million. So we will check to the left hand side of p 0.5 and to the right hand side of p is equal to 0.5. To the left hand side PL is 0 and to the right hand side this is 1. So when we examine, we find out that slope to the left hand side is positive and to the right hand side this is negative. So the graph is concave down and point is highest point along the graph of the function. Now alternative way we can determine the nature of the critical point using second derivative test as well. Nature of the critical point using second derivative test. What we will do in the second derivative test? In the second derivative test, we will take first time derivative, then we will determine the p-values, and in the third step, we will take second time derivative of the revenue function. So, p-values we already determined. This is 0.5. First time derivative we already conduct. Now, by taking second derivative of the revenue function, so r prime of p is equal to minus 8p plus 4. This is first time derivative of the revenue function. We will take second time derivative. So, r double prime of p is equal to minus 8 plus 0. R double prime of p is equal to minus 8. This is less than 0. So, it's mean second derivative at p is negative here. Now, we will examine second derivative test is this, that we will examine second derivative for the p value, that if the second derivative for the given p value is negative, then graph will be concave down and point will be highest point. But if the second derivative at the given p value is positive, then graph will be concave up and point will be lowest or minimum point along the graph of the function. So we are examining p value is 0.5. We will check p is equal to 0.5 in the second derivative for p. R double prime 0.5 is equal to minus 8. Second derivative value for p is equal to 0.5 is negative minus 8. This is less than 0, negative value. This means that graph of this function will be concave down and point is the highest point along the graph of the function. Now let me proceed toward the cost function. Cost is the function of the output produced. This means that if the company will produce more and more, so cost of the company will increase. For example, if the cost function is as given, cost is equal to 10q square minus 40q plus 1000, where quantity produced and cost is in hundreds, means the output produced will be measured in hundreds of units and cost also will be measured in hundreds of units. So the cost function is given. First part of the question is this: determine the quantity at which the cost of the company is minimum. First part of the question. So determine the quantity at which the cost of the company is minimum. So when there is minimum, we will remind the maxima and minima concept. Dear students, when you see the question like this, maximum revenue, minimum cost, maximum profit, so you will remind the optimization methodology what? Maxima or minima or critical point, because we discussed that critical point is also called maximum or minimum value of the function. So note, by using critical point location condition to determine the Q at which cost is minimum. We study in the optimization methodologies that condition for the location of the minimum or maximum point of the function. So critical point location condition to determine the Q at which cost is minimum is this critical point condition. C prime of Q must be equal to 0. What does this mean? C prime of Q is equal to 0 and we give this name 1. What does this mean? This means along the graph of the function, along the graph of the cost function, all those points at which first derivative of the cost function for the set of Q value is equal to 0, that is location of the critical point. So according to the condition, we need first derivative of the cost function. This is our cost function. So taking first term derivative of the cost function, we have C prime of Q 20Q minus 40 plus 0, C prime of Q 20Q minus 40. Now we can use the critical point location condition to define the output level to determine the number of units Q. So determine the Q using critical point condition. This is condition C prime of Q is equal to 0. How we can determine q? By putting for this c prime of q its value from the first derivative of the function. C prime of q is equal to 20q minus 40. We will replace the value of c prime of q, which is 20q minus 40, in this condition 1 for this c prime of q. So I am replacing in here by putting c prime of q 20q minus 40 in condition 1. We have this is c prime of q is equal to 0. This is critical point location condition. C prime of q 20q minus 40 is equal to 0. Solve for q. We have transfer 40 to the other side. So we add 40 to both sides. 20q minus 40 plus 40, 0 plus 40, minus 40 cancel out with plus 40, and 0 plus 40 is equal to 40. 20q is equal to 40. Now 20q is equal to 40. We are looking for q, so divide both sides by 20. 20q by 20 is equal to 40 by 20, and 20 cancel out with 20. Q is equal to 40 by 22. So q is equal to 200 units, because in the example this is given that quantity produced and cost is measured in hundreds. So this q is equal to 2 mean 100 units. 100 units. So what does this mean, q is equal to 2? This means that if the company will manufacture 200 units of output, so the cost of the company will be minimum. Second part of the question, what is the total cost of the firm producing q units of output? So total cost of the firm we can find by replacing q is equal to 2 in the cost function. By putting q is equal to 2 in the cost function, cq 10q square minus 40q plus 1000 we have. I am putting q is 2, so c up to 10 2 square minus 42 plus 1000. C2 is equal to 10 2 raised to the power 2 4 minus 42 plus 1000. C2 is equal to 10 4 40 minus 40 280 plus 1000, and C2 is equal to 1040 minus 80, and C2 is equal to 960 hundreds. So this means that the total minimum cost of the company, if the company is manufacturing 200 units, that is 960 hundreds. That is the total cost. Mean $96,000 is the minimum cost to produce the maximum 200 units of output. So simply, what is the total cost of the firm producing q units of output? Just replace q is equal to 2 in the cost function for q, and we find c cost producing 200 units, that is $96,000. Third part of the question, determine the location and nature of the critical point of the cost function. So condition of the critical point location. Condition is first derivative of the cost function for the set of q value must be equal to 0. So q value we have. We will replace for q its value 2 in the first derivative of the cost function by putting q is equal to 2 in c prime of q is equal to 20q minus 40. So we are replacing c prime of 2 is equal to 22 minus 40, c prime of 2 40 minus 40, and condition satisfied. The first derivative of the cost function at q is equal to 2 is equal to 0. So this is the interpretation. At q is equal to 2, first derivative c prime of q 20q minus 40 is 0. So the critical point 2c up 2 is the location of the critical point. Now nature of the critical point using second derivative test. Using second derivative test, we can determine the nature of the critical point easily. In the second derivative test, we will just take 2 times derivative and determine the critical values and then examine. So using second derivative test, by taking second derivative of the revenue function, of the cost function, this is not revenue function, by taking second derivative of the cost function. So first derivative of the cost function is c prime of q is equal to 20q minus 40, c double prime of q is equal to 20 minus 0, and c double prime of q is equal to 20. Now we will put q is equal to 2 in the second derivative, c double prime of q is equal to 20 to examine. We will examine the second derivative at q is equal to 2. So we are replacing for q its value 2. C double prime of 2, that is 20. 20 is greater than 0. This is positive value. So when the slope second derivative of the function for the set of q value is positive, it means the graph is concave up, and this critical point is the lowest point along the graph of the cast function. So A's second derivative is positive at q is equal to 2, graph is concave up, and point is minimum point. Nature of the critical point using first derivative test. Q is 2, we will examine to the left of 2 at nearest value and to the right of 2 at nearest value. So QL nearest value to the left hand side of 2, that is 1.9. We will check the first derivative of the cast function to the left of 2. So at 1.9 c prime 1.9 we put the values, that is negative. It's mean to the left hand side first derivative of the function is decreasing, and now to the right hand side near value at the right hand side of the 2 that is 2.1. So first derivative of the cast function we will replace for QR 2.1, and that we calculate, that is positive. So first derivative to the right hand side, that is positive. To the left hand side slope is negative. To the right hand side slope of the cast function of the critical point, that is positive. So it's mean the graph is concave up, and this point is the lowest point of the cast function.